The following problem is an example how we can determine the acceleration and the displacement of an object from a graph of its velocity versus time. So we have a graph that shows how the velocity of an object changes with respect to time. The question here is to find the acceleration of the object at time equal 30 seconds, and B, to find the displacement in the interval between 0 and 40 seconds. First, we'll remember that the acceleration is actually the slope of the velocity versus time graph. Remember, it's very important. The velocity is on the y-axis and t is on the x-axis. Any other graph will not work for this case. So in order for us to find the acceleration, we really need to find the slope of the graph at around 30 seconds. We notice that that segment of the graph is straight actually, and the slope remains constant between 20 and 40 seconds. So I can use that interval to find the slope by using the math formula rise over run. The rise here, I've marked it, and here's the run. So for the rise, I will get minus 100, which is the bottom end of the graph, minus the 100 meters per second from the top end of the graph. So for the rise, I will get minus 200. The run will be 40 minus 20. That will give me 20 seconds. So now I can actually look at the slope, which will be the rise over the run, minus 200 over 20. And that gives me for the acceleration minus 10 meters per second squared. Just for comparison, I added the acceleration at t equal 5 seconds, which is exactly in the middle between 0 and 10, and for that we'll have to do the rise over run for that portion of the graph, and that will give us 100 divided by 10, and that will be plus 10 meters per second squared. There is a coincidence that the magnitude here comes out the same. Just the way I chose the graph, it comes out that way. But pay attention, in one case the velocity is decreasing, so we have a negative acceleration, and at t5 seconds the velocity is increasing, so we have a positive acceleration. Now let's look at the displacement, which should be the area under the graph, and for the graph that gives us velocity versus time. So for that, I will actually have to look at all the areas, and I begin here with a small triangle. From 0 to 10 seconds, I'll mark it as A1, and the area will be 1/2 of the base, which is 10 seconds times the height, 100 meters per second, so that gives me 500 meters. I have used the geometric formula for the area of a right angle triangle, which is base times height divided by 2. The next segment under the graph is a rectangle. I marked it here as A2. The area of it will be simply the base, which is 20 minus 10 seconds, and the height of it is 100. So here I get 1,000 meters displacement for that portion of the graph. Then follow two areas here, A3 and A4. Geometrically, when you look at them, you can see that they correspond to two identical triangles. Only one of them is above the x-axis and the other one is below it. So I can expect the two areas to cancel. And here, if you're lazy, you can just skip and say, okay, they cancel, and you don't have to add them. But just a quick check. Let's look. The area of the triangle A3 is going to be 1/2 the base of it, which is 30 minus 20 times the height, 100. For the area of A4, I will have 1/2 the base, which is 40 minus 30 in this case, and the height of it is minus 100. So remember, if a triangle appears below the x-axis, its height has to be counted as negative. So very quickly, we can see algebraically as well that the two areas A3 plus A4 will cancel. They add up to 0, so I don't have to really add them into the total displacement. So for the displacement, for the interval between 0 and 40 seconds, I will have 4 areas that I need to add up: A1, A2, A3, and A4. I already saw that A3 and A4 add up to 0, so all I need is to add the A1 and A2, 500 and 1,000, which gives me for the answer for the displacement of that object in the interval between 0 seconds and 40 to be 1,500 meters.